Hey, Daniel.
Ira Pastor, can you hear me now?
How are you?
Pretty good here, pretty good. Trying to get you into our little Skype, and there you are. Got you in our live Skype feed.
Perfect.
Well,
Thanks so much.
welcome to the show, Ira, man, CEO of Bioquark Incorporated. Man, we're going to be talking about some amazing stuff tonight, like bio-cybernetics and generative biology and combinatorial biologics. Man, this is some good stuff. Now, tell me what's going on over there at Bioquark.
Well, we're doing a lot of fun things. We are all about going back to nature, as we say, and looking at all the amazing species that live on this planet with us that are much further advanced, let's say, than we are as humans when it comes to things like disease and regeneration and aging and, in some cases, death. And figuring out, where as humans we went wrong and in the evolutionary scheme of things, and seeing how we can awaken some of these superpowers or superhuman capabilities for the purposes of curing diseases and taking care of the big problems that seem to kill us every day on this planet. So that's been sort of our goal and what we've been focusing on the last several years.
Well, it's interesting that you're doing that, and I love that, and I feel like if humans could come up with the magic design of biology, and I guess you say I don't think it can come in a pill, but whatever that would entail, we have a lot of things against us, Ira, before we ever get there. I mean, for some, they say we're being bombarded with chemtrails. I don't mean to go conspiratorial on you, but certainly pesticides in our food and the alterations of the food matrix itself and the poisons that we have every day. Wouldn't we have to get past that for your developments to take hold, or do you believe your things can be so advanced to overcome those aspects?
Well, definitely what we're working on will help deal with the damage that those problems bring up. Whether it's the stuff in the air, all this crazy electromagnetism that's around us from the however many tens of millions of cell phones we have nowadays. Yeah, I mean, those are all extremely important in terms of hurting us. And sort of we don't usually take those things into account. I mean, we know the obvious things that we need to eat right, and not drink 5 Cokes a day and not smoke and things like that. But then, of course, living on this planet, there's just things we can't avoid. And so, yes, I mean, we're going to be able to deal with some of those issues. But as you say, it'll be nicer, it'll be more helpful in the big scheme of things if we don't have to deal with those problems in the future. And I make a point sort of when people ask about, is what you're working on, worth, as valuable as if we should solve the energy crisis first, or should we solve, abundant food production? And I say, what, if we're capable of doing what we want to do, I have faith in humanity that we will solve the other problems, that we will be able to solve energy, agriculture, cleaning the environment, and everything else. So I have faith that will come along too. It's just not my expertise.
Okay, well, I'm glad you're bringing some faith to the program there, Ira, because there does seem to be a number of negatives against the human race. As I look across the planet here, and I'm not seeing a lot of positivity, I guess I should say. We do a good job of destroying ourselves in a lot of cases. Of course, the pollution that we have. I mean, it wasn't too long ago somebody at the EPA pulled the wrong valve and completely obliterated a river out west, and with mining debris. And so, and of course, you're gonna have your classic oil spills. You got Fukushima out there. of course, we mentioned genetically modified foods and various poisons. But I admire you being so positive, and in your position, you need to be that positive. And I guess coming from a position of positivity will thrust your mission forward. You really certainly can't be looking, but these are factors. So you've got a lot of things arrayed against you. But is there any what you do in your team? Do they take any of that into account, or are you simply just on a mission to move forward with evolutionary genomics?
Well, I come out of the sort of evil pharmaceutical industry. I spent the last 30 years there, in essence, before I got involved in what I was doing here. And the reason I got out of it is because after generating $1 trillion a year and spending $200 billion every year on new R&D, I knew that what we were doing wasn't really coming up with anything to cure humanity of these big problems, whether it's Alzheimer's or cancer or heart disease or take your pick of the what we'll call the big chronic diseases that kill us at the end of the day and make us degenerate, suffer, and die. We were very good at making treatments for things. We're good at lowering your cholesterol and stopping pain and things of this nature. But the real big problems we weren't really addressing. And I look at it from the outside now as really they were incapable of doing it. So people always say, well, aren't you afraid that this $1 trillion industry is just going to, is going to stonewall and wipe you out at some point? And I say no. I mean, it's because they've brought it upon themselves. These huge companies with 50, 60, 70 billion dollars a year in revenues, which are losing all their patents now to competition, and at the same time, they're promising the folks in Wall Street this amazing growth. Now, that doesn't add up. So it's got to come from somewhere new. So, we're pretty positive that whether Big Pharma jumps on today or 5 years from now, we're pretty confident in what we're doing because we know they're going to need it, because we've come to the end, as you were just saying, pills and bottles. It's not going to be pills and bottles from the local Rite Aid in the future. When you're talking about the big stuff, if your arm is chopped off and we want to regrow it, that's not going to be a little white pill in a bottle from Rite Aid. It's the thing that is going to look very different. So there's going to be a different industry that starts. It's going to be much different. And, we made a decision. We're not a genetic engineering company. We're much more of a, we're much more in studying nature and finding out what 3 billion plus years has done, whether it's plants or frogs or newts or salamanders, and learning, learning from the natural world.
Okay, well, I'll tell you what. You mentioned salamanders. I'm going to show the folks out there a salamander. This thing is called. Let's see what is this called here? You probably can help me on this. Is it a axolotus?
Yeah. Well, I pronounce it axolotl, but they're from down in Mexico, and down there they pronounce it with like a J.
Okay.
I don't exactly know how they pronounce it.
Okay. Well, they're looking at this thing right now, and I tell you, it is one cute little creature for sure. So now, and here I don't know if it's got like 3 or 4 ears flying out of there, but now this is the salamander that I know he can grow feet and different things. I mean, could he grow a head? I mean, how much can this guy grow?
Let me tell you what that guy can do.
Let's hear it.
He's fascinating. You can chop its arms off; it'll grow back. You can chop its legs off; they'll grow back. You can sever its spinal cord; it will grow back and no longer be paralyzed. You could blow its brains apart with the equivalent of a shotgun. That brain will come back. And the other interesting thing that little fella can do, you can give him cancer with some of the nastiest carcinogens you can think of, from Fukushima or wherever, and it will develop cancer, and then it will get rid of cancer like it was the common cold.
Wow.
There's so much. Now, you can't chop his head off and it'll grow back. There's other species that do that. Certain planarian worms and other species can grow a new head with a new brain. You can't do that to him. But interestingly enough, we can get back to this. You can pull his brain out
Okay.
in major parts of it regrow, and strangely enough, and this is one of those weird aspects of my field that has never been explained, he'll remember stuff in the new brain from before you pulled out the old brain. So he can do a lot of miraculous things, many which are not explained by conventional biology.
I
But
like
he
him.
is one example. He's one example of something that we need to respect, and he's endangered. So
Oh.
we got to be careful
No,
with.
no, who would hurt that little guy? I think he's cute as buttons, man. I'll tell you what, I'd like to see a few of them run around here. But yeah, now you talk about pharmaceuticals, man. Now the giant pharmaceutical company Eli Lilly is right here in Indianapolis, and they do a lot of good actually. But there's always this thing when it's almost kind of like plumbers or mechanics. You kind of almost want to have a negative kind of outlook on it, like they're up to something and they're not for your best interest. And there's all these rumors, Ira, that said, they have cures, but they're not releasing them, or that they have enough of a drug manufactured to keep you on that drug, but not enough to cure you, but to keep you coming back. Are those just euphemisms? Are those made up stories, or do they do that?
Um, the nature of that business, and I'll say the traditional pharmaceutical business, is to make things that interfere with your symptoms. So I point out, the pain that you feel in your osteoarthritis, as an example, I don't know if you have arthritis, but just an example, is not the osteoarthritis. That is a symptom of it. The redness or the immune response in my psoriasis is not psoriasis. It is the symptom of it. So
Mm-hmm.
Big Pharma the last 100 years has been very good at interfering, whether it's with chemicals or whether it's with proteins, biologics, things like that, interfering with once you're sick. However, that's a treatment. A cure is a very different thing. A cure is basically taking you in, if you have diabetes, and wiping out the diabetic situation so you no longer have diabetes.
Mm-hmm.
They're very different things. They sound the same, but I make the analogy, it's not like asking, General Motors to stop making internal combustion engine cars and make electric cars. It would be like asking General Motors to, stop making cars entirely
Mm-hmm.
and make, flying vehicles or something of this nature.
Mm-hmm.
So cures are very different. And honestly, pharma is just not prepared to make them. They are not thinking how you cure something. It's much more complicated than just doing what they do, which like makes nice little chemicals and so forth. And that's, Eli Lilly is an example. I mean, nothing against Eli Lilly. I know them pretty well, but think about it. I mean, they're built on insulin. Insulin was discovered and developed 100 years ago. I mean, we don't think about it, but 100 years ago, a couple guys came up with that concept. Still one of the major, but we still can't reverse diabetes. Okay,
Yeah.
insulin, keeps you going, right?
Mm-hmm.
Keeps millions of diabetics chugging along, but we still haven't come up with a way to take diabetes and erase it from your system. So tomorrow you wake up and you will no longer diabetic.
Mm-hmm.
That's a cure,
All right.
and it's a very different process. And so it's what we're going to be bringing to the table.
All right. A question came in from a live chat. It says, "Has your company found any cures?"
Yeah, well, we've been, yes, we are very active in several areas. We're active in the central nervous system, and we're active in the area of oncology. In the central nervous system, we've been having some fascinating results in terms of traumatic brain injury and spinal cord injury in regard to regenerating and reconnecting neurons in paralyzed subjects. And this has been extremely exciting for us because at the end of the day, you get a spinal cord lesion nowadays, traditionally, you're in a wheelchair the rest of your life.
Yeah.
So this has been something that we've been very active in. The other area, oncology, less advanced, but what we are working on, and this is a very exciting sort of piece of the puzzle, as we're just talking about that little fellow you brought up, when he gets cancer, he doesn't kill it. All he does is he turns it back into normal tissue. And so the oncology system for the last 50 plus years has been focused on killing cancer. Sort of thing, it sounds makes okay, this thing growing in me, want to kill it. But no species on this planet that is resilient and resistant to cancer kills it. They just turn it into something else. They turn it back into the natural, normal tissue. So we are working on drug substances that can do that as well. So no longer think of chemotherapy, no longer think of sort of the smart bomb drugs. We're talking about taking that tumor in the breast, in the lungs, in the brain, and turning it into normal tissue.
And for those of you just joined the broadcast, we have on our Newsmaker line via Skype, Ira, a pastor of Bioquark Incorporated. If you have a question for Ira, you can click on the Fast Blast link on the left side of the Edge's website, or join him in a live chat on our website, or the live chat going on our streaming YouTube channel as well. Ira, back in ancient times, there are stories of people that lived hundreds of years. Do you think that they perhaps lived on a planet that was conducive to health? The air was pure, the vitamins were everywhere. I mean, and so they had an atmosphere, a world conditions that were conducive to extreme aging. And then, of course, over time, maybe it got depleted or something traumatic happened. Or do you think these stories are just made up and no one really lived that long?
I would love to have a time machine and to go back and see what was going on. But I can tell you one thing. Most species on this planet that are around today, that were around hundreds of millions of years ago, that either have extended lifespan, so I'm talking about hundreds, if not thousands of years, or have significant resilience to disease, do two things. It's just general things.
Right.
They either take very little from this planet, or they give a lot back to it. So, trees, they like to clean the air and the water. They pull out carbon dioxide, and they feed other animals. And they're part of a system. We as humans are very disconnected. Despite all the stuff, our connections on the iPhones and the internet nowadays, we've become very disconnected from the natural world. And we forget that for the last several thousand years, the natural world was the source of all our health care. And even today, as we speak, 85% of all drugs that are still produced had their origins from plants, bacteria, fungi. So we need to sort of show respect to not just the components of it, but to the system itself. And I think, whether Methuselah lived 900 whatever years, I don't know. We can go check it out when we get the time machine. But clearly, we were very different then in how we sort of looked at this world.
But there is archaeological evidence that things were huge. I mean, I believe Israel, they found grapes the size of basketballs. Of course, the animals were all giant, and this goes into conspiratorial area again, because I love it over there. It's my alter world. But there's giants. There's evidence that there were giants, humans at some point. Now, either somebody's making bones and sticking them in the ground and letting people find them and giving them the look of antiquity, or they really did exist. So I'm just thinking that there might have been a sort of a world that's vastly different from what it is right now. All right, let's go. Go ahead.
Go ahead.
All right. Next question. Does Bioquark want to bring a dead body back to life? Is that in your plans, Ira?
Well,
Doctor?
Let me give you the background on that. So, a couple of years ago, we got involved in a project that was focusing on an area of research very little known to many people, but which has been performed in the United States for 30 plus years now, performed in other countries, and that is living cadaver research. It is a form of research where people who donate their bodies to science upon their death are kept alive. In the sense, and when I say kept alive, when you are declared dead in the United States, it is based on the brain death definition. So your brain is irreversibly damaged. But for the last 100 years, we've gotten pretty good at keeping lungs breathing and hearts beating. And in many cases, research is done using subjects that are still living, in the sense they're living cadaver.
Okay.
We wanted to merge together this research path with our understanding of nerve and neural regeneration in 2018, because brain death, as we define it today, was defined back in 1968 at Harvard Medical School. It's 50 years later. So when you combine that with the fact that, as we were mentioning, there are many species on this planet whose brains can come back and regenerate in entirety, we put three things together, and he said it's probably a good time when it comes to all of the disorders of consciousness, not just death and brain death, but coma, persistent vegetative state, to begin to explore what it would take to revive patients whose brains are severely damaged, if not irreversibly damaged, per the definition. So it is a research program of ours. We are far from bringing someone technically dead back to life, but if we can bridge the gap initially between what it means to be in a deep coma, which is the sort of the deepest state of being alive before death, and death, that will be a major achievement and something that we think is legitimate.
So if I went to your company, would I find a room with a guy standing in it, and he'd be saying, "Okay, bring in the dead guy"?
No, not at all.
Okay.
You would find a lot of lizards and frogs and rabbits and guinea pigs and cats and things of that nature.
Wait a minute, Ira. What are you doing to the little bunnies, man?
Well, bunnies get cancer too, unfortunately. Everything on this planet, unfortunately, gets cancer at some point.
All right. Well, I got some rabbits running around my yard, man. I can always tell because of the snow, man. There are little footprints going on there. All right. Doug White has this question, and I might get this title wrong, but it says, What do telomeres have to do with your research? That's telomeres.
Sure. So telomeres, just for people who don't know what they are, they're basically, I can explain them, sort of like the ends of your shoelaces, that little plastic part that keeps your shoelaces on your shoes from fraying. We find them inside our cells on the end of our chromosomes, and they're a way that keeps chromosomes stable. Once chromosomes over time, via cell division, become unstable, cells eventually wind down and enter a stage of senescence, where they don't die, but they sort of become dormant and don't do what they're supposed to do anymore. One of the signs of aging. We are active. We are not specifically focused on telomere research in the sense of specifically targeting telomeres, because by themselves, if you make telomeres extremely long, there's potential for cancer development, as they are if they're too short. But in our studies basically on how you rewind cellular age entirely and take a cell that is 50 years old and erase its age and bring it back to a state of being 10 years old, telomeres are part of the process of and there is a telomere elongation process that naturally occurs in that component of our research. Telomeres are important. The question sort of is being debated is, are they a cause of aging, or are they a sort of a sign of aging? I don't think the people that debate that have an answer for it, but it is sort of one of many components of the aging process that need to be taken into account when resetting the age of a cell to zero.
Yeah. As far as your work, obviously it sounds like you're working on aging and perhaps maybe even death reversal. Are you eventually working toward a path to immortality?
Well, look, if death, if one solves both death reversal and aging, then some severe, sociological, societal implications will arise. Now, that's not to say that the meteor strike or a lightning bolt or various other things will not kill you. But at the end of the day, we lose 160,000 people every day due to two things. 100,000, 110,000 we lose due to the diseases of just the aging process, 50,000 to acute trauma. So clearly, that is something that we need to keep on the radar, that immortality or substantially elongated lifespans because of eliminating aging and premature death is a possibility. Now, that does not mean you're going to live to 1,000,000 years or anything, but we're talking initially on the concept of health span. So Will you live 500 years? Possibly. But more importantly, in the short term for us and our thinking with how we're doing development, is making 90 the new 40.
Hmm.
And if you can be vibrant and healthy in your 90s as you are in your 40s, that we think there's some benefit there
Hmm.
to everybody.
So right now, for a healthy person, just the overall health picture, and I guess worldwide, I would say the average human, is 50 the new 40, or is it still 50-50? 50 is 50, because they always say that 60 is the new 50, or they say,
Right.
I don't know, is that just a marketing term, or is that based on fact?
I think that makes sense if you're doing everything the right way, you're not smoking and eating and exercising and doing the basic things that everyone sort of knows they should be doing. However, at the same time, if you look at the outliers, the longest lived human ever, Madame Jeanne Calment in France, she lived to almost 123, and she smoked until she was 102. So
Mm-hmm.
the outliers do not always, it does not always a healthy lifestyle.
Right. Yeah.
That leads that way.
George Burns did what, a shot of whiskey and a cigar every morning, and he went to 92.
Absolutely.
So
And Winston Churchill too.
isn't there something though in each person's personal biology? I mean that dictates a large portion of their life expectancy.
Genetics is a major part of it, but also sort of the epigenetics, which is sort of the
Mm-hmm.
new area. Not just the genes themselves,
Yeah.
but the
Well,
chemical modifications, the things that are attached to the genes,
mm-hmm.
the things that turn a gene on and off.
Yeah, the switches.
The switches, exactly, and whether that. Depending on how much they're affected by whether I smoke a lot or whether I don't smoke or whether I do X, Y, or Z, we're only really beginning to understand this.
Okay. Is it possible? You have something like a me and what was it called? Me and 23. It's you can send your blood in and check your ancestry. Is it possible from the gathering data from there to find out who's going to live the longest and maybe take the highest attributes or some part of their DNA and mix it with others and sort of build it up? Say this person's family has a tendency to live to 80. This person's family has a tendency to live to 90, and start gathering those parts and try to create something from that, or no?
Yeah, I mean there are people that do that, especially in sort of it's called the super centenarian research. It's the analyzing the blood and so forth. The people that are 110 and over. Genes are important. The problem is, and this is one thing, when we've done the Human Genome Project about 20 years ago, sort of the genes took center stage. But what we're really beginning to realize is, by themselves, they don't do anything, right? Genes are just holders of information. They just give little clues on how to build amino acids, which themselves don't do anything. They just are parts of proteins and so forth. So, in our opinion, yeah, the genes are important. But whether you are going to, whether you can tell whether you're going to develop cancer in 30 years based on some mutation you have versus not, a lot of that is nonsense at this point in time, because you have no idea sort of the microenvironmental dynamics that are feeding into the genes, or whether a gene is going to be, as you said, switched on or off 30 years from now.
Okay. All right. We have this question from George. It says, Ira, is chemotherapy a failure, and if so, why?
Oh, it's a major failure. So just stepping back for a minute, we have 14 million new cancer diagnoses every year around the world. 8 million people will die. These are the numbers. And for the last, since the war on cancer began half a century ago, the primary focus has been to kill. That there is this cell here, we can target it, let's blast away, whether it's chemotherapy or whether it's these other new forms, immunotherapy, cancer vaccines, things of this nature. It's always been a kill-centric approach. The problem is, when you kill either method, you're killing healthy things as well. You use chemotherapy, you can blast away a lot of bad stuff, but you're going to be blasting away a lot of good things as well. And what we're only beginning to realize is the good stuff, the good cells, are not just important because they're healthy cells.
Right.
In many ways, they help keep the remaining cancer that isn't killed in check. And if you blast away the good things with the bad, you let the really tough cells that remain run amok. This is also the problem, unfortunately, with the newer therapies, because as they've gotten very targeted now, and say, hey, we can target a gene or a specific cell in a cancer or a tumor, we're forgetting that if there's only certain cells in that tumor that have that gene mutation, we're leaving the rest behind. So whether we're talking about shotgun chemotherapy or sniper rifle immunotherapy, we're missing sort of the big picture that we got to keep in mind that there are healthy cells there that have a role in controlling tumor formation in the first place, and we can't blow those away. And it's just, and this is just one side note, is an interesting fact for the audience. As we're sitting here right now having this discussion over this next hour, we're all fighting cancer behind the scenes. The little transformations that occur in our body on a daily basis throughout our life are kept in check by the healthy cells that are not transformed. We don't want to kill those off, and that's been one of the major problems of chemotherapy, not just the toxicities involved with it. When you kill off the healthy stuff, you proliferate the really bad stuff you leave behind.
Ira, there is on YouTube 3D animations of something called nanobots, where there's some kind of hope that a miniature machine of some kind, a miniature robot, will actually go through our bloodstream and kill cancer type cells individually. Is there any hope with that technology?
I think that whole area, and I don't want to speak out of turn because I'm not a sort of nanotechnology guy. From what I understand, because I do sort of roll in similar circles with folks like that, they've gotten very good at making things small, very small. I think the main question is how you power a teeny little robot, and then how you sort of getting in the sci-fi realm, but how you swarm them appropriately, because we are, all of us, on average, made up about 50 trillion cells. So to take care of problems throughout the body, you need billions of these little robots swarming together the right way, going to the right places, communicating, and so forth. I think that is a little further out. I think right now they got very good at making little stuff, but what they can do with it is still a little ways out.
All right. Azure from our YouTube chat has this question. Do companies withhold cures for profit, or is there really are there really cures for cancer that we don't know about?
Based on my experience, no, there are no cures. I'll take that back. The last cure that I'm very confident that our industry created was the antibiotic. If you remember when that was about 100 years ago.
Wow.
And antibiotics don't really affect us per se. They are killing bacteria, fungi, things of that nature. Cures, as I was mentioning earlier, are just very difficult, because to cure you of any disease requires that we erase the disease, not just impact its progression.
Right.
And so, at least from my 30 years being inside the beast, they never worked on that stuff. It was just beyond the way they thought. They were very good, once again, at making little chemicals that they could put in pills, that they could sell at the local store, that you take the rest of your life. But to cure you is not that. Cure you is get rid of the disease. We get rid of you. You will no longer be diabetic. You will no longer have an Alzheimer's. You will no longer have Parkinson's disease at point X.
Yeah. Now, if you go to a retirement home, you will find a lot of the customers or guests or whoever how you want to put them, they would have these pill cases. And maybe people outside of there do too. The elderly sometimes say, and there'll be 15 pills in there, and each pill is designed to do something, and one pill is supposed to mitigate the effects of the other pill. And so you got these. Have you seen that? Yeah. Is it best just to stay away from pills altogether if you come to that point?
Let me tell you something. And once again, I'm an ex-pharma industry guy. I have slightly elevated blood pressure. The only pill I take a blood pressure pill every day. I wish I didn't have to do it. If I didn't have to take anything, I wouldn't. The reason being, and just once again, a little sort of background for the audience, everything that you take a pill for to interfere with nowadays, your body has a natural response to it. I take this pill, and every day my blood pressure goes down a little bit, and then I pee it out, and my blood pressure comes back up a little bit. because it's the normal state that my body's in at that point.
Mm-hmm.
So your body, whether it's pain, whether it's sugar levels, whether it's blood pressure, it naturally regulates things. If I take a pill and I'm adding, it loses its normal ability to do it.
Mm-hmm.
I would love for my body today to be able to say, hey, I don't have this anymore, but we're not there. We don't have that yet. So I do take that blood pressure pill every day.
Mm-hmm.
But if I didn't have to, no way. I wouldn't
Um,
take anything except my daily vitamin and aspirin.
God forbid you would get cancer. Would you take chemotherapy?
That's a tough one. I guess would depend on the diagnosis and how late stage, and knowing the success rates later on in later stage disease versus early stage disease. There are a lot of things going into it. Hopefully, I will never have to have that situation.
Mm-hmm.
But once again, it would depend on sort of the severity, what type cancer, and so forth.
Yeah.
But I would
Yeah.
definitely let's say I would use my knowledge of all the alternatives as well.
Yeah. I mean, I know a lot of people at that time, they do a furious search on the internet for alternative cures. Many of them come up with uh, just basic diet changes, to be more acidic or otherwise, to try to bypass that. But in the end, it's a horrible choice for anybody to make. This is from John from Pennsylvania on our Fast Blast. It says, do you know about cancer pioneers like Max Gersey, Harry Hoxsey, Royal Raymond Rife? I don't know. These are cancer researchers, I guess.
Yeah, there are a lot of I don't call them alternative medicine, but to me, it's all medicine, right? It's just the pharmaceuticals are one thing. All of these are interventions of some type. I don't know about the specific. I know of Hoxsey, some of the history there, but there is a wide range of history around various natural therapies of different types, different diets, different sort of, as you were mentioning, acidification versus alkalinity and so forth. And honestly, they all, in some cases, work. And, I go by the belief, it's not my statement, I'm stealing it from someone else, but you really need to listen to your body. Because you're just pointing out, before when we were talking about genetics, we are all different. Technically, every disease, whether I have diabetes or you have diabetes or someone else does, it's all slightly different. Just like any cancer case is slightly different. And so, going back to the question, I would look for all possibilities, whether they were existing drugs, alternative therapies. And one thing I want to point out for the audience, and this is important because it's a major problem. In this country and abroad, we have a major, what we'll call a clinical trial gap. It's estimated for something like cancer nowadays, less than 5% of all patients who get cancer in the United States will ever seek out a clinical trial. Okay?
Mm-hmm.
They don't know how to do it, they don't know where to go, but there's thousands of clinical trials. And I really recommend that anyone, even just healthy people, get familiar with databases like clinicaltrials.gov, which lists every clinical trial in the world going on. And you might find out, hey, in Indiana somewhere, there's a gene therapy for something happening. You need to know about these things because the existing medical system is you're going to fall off a cliff at some point, and you have to look for opportunities.
Yeah, Ira, we had a doctor from England on the program last year, and he claimed that he's cured. Go to that word cured. I thought he said on the order of 30,000 people from cancer, and he said he did it simply by having them change their lifestyle without the use of drugs of any kind. And really, he said it was basically rooted in stress. It could be bad relationships. It could be problems at work. If work is bringing you stress, just quit, go to another job. I mean, he worked like that, and he claims to have major success. I wonder, is that type of thing ever come into your company's thinking as far as in addition to your technology, these sort of peripheral things about a person's lifestyle, how they live, what they think about, are they nervous, are they fearful type of thing?
Absolutely. And this is extremely important. If you go in the literature, you will find thousands of cases of spontaneous remission in cancer. They don't know why, but they exist, and you cannot overlook these, because spontaneous remission is something that flies in the face of cancer in the first place, because if cancer is just these mutations that are changing, spontaneous remission would, well, that doesn't mean it's reverse mutation, it means something else is happening. What we are seeing, and whether we're talking about stress, or whether we're talking about meditation, or other factors that do not have a biochemical component, but are involved in thoughts, magnetism, light, sound waves, everything that goes inside our brain, and sort of the natural way we sort of just live our daily lives, all affects, it trickles down to our biology. And a lot of this stuff, you have to remember, was around 100 years ago. I point out that, if we went, back in a time machine 100 years to a biology lab somewhere, they'd be talking about these concepts that we're only coming back in phase today. We're talking about, you wouldn't hear about like biology as much, you hear about fields and forces. And now, in 2018, we're beginning to realize it's more than just biochemical stuff occurring in our bodies. Our thoughts, via electricity, via the magnetic fields that our brain generates, and other parts of our body, we affect things biophysically as well. Mm-hmm. So obviously, yes. I mean, although it's seen in the past as sort of a fringe area, no doubt you can think yourself into sickness, and no doubt you can think yourself well.
Oh, Ira, that sweet little salamander we were talking about earlier. What would you do with that creature to get the information or of how he regenerates so well?
Well, fortunately, he and his friends, the newt, the frog, everybody else in that kingdom, have been studied for 90 years now in the so-called regenerative biology era. So there was a period of time where thousands of his type were sacrificed at the altar of science, where limbs and spinal cords and eyeballs were pulled out and brains chopped in half and so forth. A lot of nasty stuff was done to his ancestors.
Hopefully they don't hold a grudge.
Yeah, hopefully not. But a lot of that literature is in the public domain. We study the genes, the proteins, the microRNA, all the biofactors that are involved in his regenerating brain, his heart, his eyeball, his limbs. And we look to see what the differences are between what happens in him and what happens in a human. Because when our arm gets chopped off, we get scar tissue.
Right.
We don't get a new arm. Oh. So we want to understand the differences that exist. And this is part of this, as I was saying, this evolutionary genomics you were mentioning. The genes are pretty much the same, strangely enough. What is different are how those genes are turned on and off. And so that's what we're very interested in. And one only needs to look at developing humans inside their mother's wombs to see that, hey, we had webbed hands and feet when we were in there, and gills and tails and things like that.
And what's up with the tail? What's up with the tail, though?
No, goes back to the fish. I'll leave it at that. But the fact that genetically we're related, and the genome, let's just say, can remember, we are looking for the signals, the different stimuli, whether they're chemical, biologic, electrical, that allow that program for regeneration, as opposed to scar formation, to occur. And the one very important thing that is part of this puzzle, that little guy is not, but we bleed a lot. Humans are horrible bleeders. We bleed very quickly.
Now, now in the early days, didn't they believe that if you could just drain a person's body out, they would drain your blood out and say, hey, that was a technique used by doctors at some point?
It was a technique used by doctors at one point. And the odd part of it is, and I don't know how many in the audience know this, but leeches, which George Washington was used for this purpose, were approved by FDA several years ago as medicine in the United States. Not for bleeding people, but for helping to heal non-healing wounds, because they found out that the little leech, when it chews on the wound, it secretes saliva that helps you heal faster. So it's one of those weird situations. It's funny you bring that up, that, what was old medicine 300 years ago has now made its way back in, not just into alternative medicine, but actual medicine that Food and Drug Administration approved.
Yeah,
you can buy medical leeches now.
Yeah, it seemed like I think there was a scene in the movie Gladiator where the main guy was cut and they put maggots in his wound. So maybe maggots could be our friend, Ira.
Maggots are already approved. There's a company in California called Medical Maggots, which produces them for the same purpose. So not everything is a little white pill in a bottle, and we need to respect nature.
Sometimes it's a gross little slug getting in there.
Exactly.
Listen, Ira, hey, we're right at the top of the hour. We take a 5-minute break. We'll take you out of the picture here for about 5 minutes, but before we do, why don't you tell us a little bit about Bioquark and what they can find on your website?
Yeah, www.bioquark.com, Bioquark. Come to our website, learn about our programs, our research, everything we have going on, and contact us if you have any questions. We're an open book. We love talking about what we do.
Okay. All right, just stay on the line, or you don't have to sit at your desk here. You take a break yourself. We'll be right back with you.
Cool.
All right. All right, everybody, you're watching and or listening to the Edge Television broadcast. On our Newsmaker line tonight is Ira Pastor of Bioquark Incorporated. This program will begin to replay directly after the show, and we'll put it up in our TuneIn Radio playlist, and we'll put it up in our YouTube channel as well. We're going to take a 5-minute break. We'll be right back. And welcome back to the Edge Television broadcast. My name is Daniel Ott. If you miss any of the exciting first hour and begin to replay in our main player directly after the show, we'll extract the guest portion of the video and put it in our YouTube channel, and we'll also put the audio into our TuneIn Radio playlist that plays our show 24 hours a day across any platform, any device. Of course, we'll also podcast it for those of you who love podcasting. Next week, we're going to have with us Josh Peck talking about the day the Earth stands still. So come back and see us next week as well. If we haven't had guests on the program you'd like to see, drop me a line at edgeam@yahoo.com. Now let's go back to our Newsmaker line and bring back with us Ira Pastor of Bioquark Incorporated. Ira, welcome back.
Thanks for having me.
All right. Well, I'll tell you what. We in the first hour we were talking about a lot of things. I'm going to ask another question. A number of questions started popping in about blood types, and there's a lot of talk on the internet about what the best blood type is, and a lot of times RH comes up. Is there any advancement in the blood type that it leads you a certain direction, or you go through all of them?
That's a little bit outside of my realm. I obviously, if you're AB and you're a universal recipient, I guess you have the ability to access the widest range. More on our side with regard to blood has to do with sort of all the nasty stuff that floats around in it, whether you're AB, O, what have you, in a lifetime. Because recent studies show that right now, sitting here, you have something like 4,000 chemicals of various types, whether it's pollutants or drugs or food metabolites, things like that, that are just spinning through your system. So it's something we have to get better at cleaning, let's put it that way, and getting all the bad stuff out, and not pumping through 24 hours a day constantly. But as far as a rhesus factor and so forth, I'm probably not the guy to ask about that.
Is there any possibility, again, I'm just using salamander as one of many organisms out there, the merging of human and, they've got genetically modified foods out there, where they have a salmon mixed with a tomato. Do you at any point see mixing of these types of animals' DNA or blood together to see if you could inject the DNA of a salamander to human, would he pop out some arms and some gills and stuff?
No, because once again, at the end of the day, the one thing that they really didn't talk much about when they finished the Human Genome Project about 20 years ago, when they were all excited about decoding the human DNA. The fact is that there wasn't much different between us and monkeys and dogs and snakes, and the genes were pretty much the same. And so at the end of the day, we have, that's sort of all, part of sort of our mission. We have the genes, whether we want to develop other superpowers
Mm-hmm.
of various types, whether that is, being able to see electromagnetic fields like birds can, or see an infrared, spectrum like wolves, and
Mm-hmm.
so forth.
Mm-hmm.
Um, Strangely enough, we have a lot of those capabilities already. Just
Mm-hmm.
it's the level
Mm-hmm.
of
Well, I think it was
the
I think
gene
it was
expression that would need to be turned up.
well, I think it was the cod actually that they mixed the tomato with, but and to give it a cold a version of
Resistance,
cold,
yeah.
resistance to cold. So that type of thing is that a step in the right direction?
Um, I can't speak much about that. I tell you, the one thing that is kind of interesting is the ability to take pigs, which have a very sort of similar heart, and a lot of similar organs to humans, with the exception of sort of some of the genetic components that says that, hey, I'm a pig,
Mm-hmm.
and wiping them out and sort of
Mm-hmm.
replacing them with the human genes.
Mm-hmm.
So you're not getting a smart pig per se, like a human, but you are getting a pig that grows organs that are basically non-rejectable by
Ira,
humans.
let me ask you something. The technology is just seems like it's just advancing so fast. I mean, we got robots everywhere now. Google says within 25 years that you'll be able to take the consciousness of a human and put it into a robot. But that's technology in the field of uh, um, biologics. Why isn't it advancing as fast as technology, or is it?
Um, it's the possibilities are there. This is just a much longer regulatory path. I mean, this is, I always point out for people who want to get into this business, this isn't like creating an app on the cell phone.
Right, I can see that.
You're not gonna become wealthy in 6 months of getting involved in
Mm-hmm.
biotech. In
Mm-hmm.
fact, I point out that you will most likely fail the majority of your career, because
Wow.
the odds of getting a new drug to market are something like 1 in 40,000
Mm-hmm.
now. So I say, if you have thick skin and you're not afraid of rejection, and you're not afraid of sort of the negativity that comes from everybody else
Mm-hmm.
that has failed, get involved in this space. It
Mm-hmm.
can be extremely exciting.
Mm-hmm.
I think the things that we are doing are going to eclipse whether it's robots, artificial intelligence, or things of this nature.
Mm-hmm.
And not to put a bad light on that, I
Mm-hmm.
think all that stuff's great, but I think some of what's coming in terms of the human condition or the biologic condition are going to be, if not
Is
more,
okay?
fast.
Miss Freedom out of the YouTube channel chat asked this question. What about the fact that young blood can regenerate an older person? Is that true? Is that possible?
Um, yeah, I mean, she's talking about the what's known as parabiosis, where basically they take the young blood and put it into older subjects and
Mm-hmm.
see how things go. And for the most part, yes, there have been rejuvenation effects. The sort of the debate that's going on now in that area is whether there are young things, youthful factors in young blood that are making an older person youthful, or whether that blood is just diluting away
Mm-hmm.
the bad stuff that we were talking
Yeah.
about, those thousands of chemicals that are floating around in an old body.
Mm-hmm.
The consensus is it's the latter.
Mm-hmm.
So we need to do a better job on figuring out how to stop all that junk from pouring into the bloodstream in the first place, or else you're going to have to take the blood, like a vampire,
Yeah,
all the
well,
time.
all right. Well, I were pastor in the first hour. We were talking about reanimation of a corpse. There's a video out there, been out there forever, of I guess Russians taking a dog head and sewing it onto another dog. Did that really happen?
According to the video, it did. And there's a gentleman, Sergio Canavero, over in Italy right now that wants to try the first human head transplant this year. Out of it, he's out of Italy. He's setting things up in China. Obviously, he has to deal with the issue of reconnecting appropriately a head to another body and reconnecting the nerves and the blood flow.
I just hope they don't. I hope they don't put a human head on a dog's body. That's going to be creepy, Ira. That's creepy.
I don't want to see that. I don't want to see that either. But what I do point out is that head transplants and brain transplantation, it has been going on for decades now in other species. So I point to the research of a guy out of University of Indiana named Paul Piche back in the 1970s, where he would exchange the brains of frogs and salamanders. This was really interesting work because one was a vegetarian and one was a carnivore, and when you switch the brains
Wow.
around, you saw the change in the feeding. But
Jeez.
yeah, I'm not a head transplant guy, but if you
I'm really
can,
glad. I'm really glad, Ira. Hey, on another note, how do you respond to religious critics that may suggest that Bioquark is playing God?
Um, well, the playing God argument has been around for a long time, and that argument was raised 100 years ago when we first developed organ transplantation, when we first developed cardiac defib technology, when we first developed artificial breathing technologies. I say, look, we're not deciding who lives and who dies like God. We're just trying to help out a bit in
Mm-hmm.
cases
I
that
just want to help.
a little too premature. So if someone wants to criticize us because their 3-year-old daughter accidentally fell in a swimming pool and drowned,
Mm-hmm.
or their 16-year-old son flew off a motorcycle without his helmet on, and they just want to accept sorry, there's nothing else we can do for them
Mm-hmm.
from an industry that generates $7 trillion a year, I say, well, you know what? No, we're not playing God. We're helping out a little
Mm-hmm.
bit. And then I have to point out to other religious factors that, look, if God put us in this sort of Garden of Eden of other species that can die and come back. So I would hesitate to think that he would not want us to learn from the world around us
Yeah.
and to learn these capabilities. And I'll leave it at that.
Did you ever see the movie Deep Blue Sea?
Sure, with the sharks. Sure, the
Yeah.
Alzheimer's and
Okay. Okay. And as you know, the thesis of that movie is they were growing giant sharks so they could get a chemical out of the shark's brain. But what happened? It didn't really work out too well. The shark evidently moved way past the evolutionary trend and became a carnivore attack species, attacking in herds with recognizing cameras and guns. Do you ever feel like you might cross a line, Ira, by any of the research you guys do?
Not at all, because we're not doing any genetic engineering, no genetic modification, no tissue engineering of any type, no chimera production. Everything we're doing is based on stimulating what the humans already have and just upregulating it a bit.
Mm-hmm.
So we do not foresee anything along the Hollywood spectrum of things being a problem for
Okay.
our research.
Okay, I'm going to switch over, and I'm going to show the folks a video. I don't know if you're watching. Are you watching the show?
Mm-hmm.
Okay. I mean, are you seeing the video? Are you just seeing me, or are you seeing the whole show?
No, I'm seeing you, but go ahead.
Okay. Well, anyway, what I'm going to play right now. Just a video just came out of. I think it was from Northwestern University. They captured the moment that a sperm enters into a egg, and there is
Right.
an illumination. Let me get this video up and show the folks. I'm going to jump out of the picture here real quick and let
Yeah,
them
I'm familiar.
see.
End of the video.
You're familiar with that?
Oh yeah, yeah.
Okay. All right, here it is right here. Okay. Oh, got a little music with it too. I didn't know that. Okay. So yeah, what they say is it's like a zinc firework, and there's various eggs there, and a sperm. I guess only one sperm can go in there, but then there's this luminescence that hits. Now they just claim that that's zinc fireworks. How do we know that that's not the actual spark of life?
Maybe it's both. In the sense, not everything that goes on inside your body is biochemical. As I said, inside your body right now, aside from everything that's going on, you have electricity, you have magnetism, you have light, you have sound waves. You have a lot of physical stuff going on. Yeah, so it most likely is a spark of many things happening along those lines. What is very important in that video, which sort of is not discussed as much, but should be and should be told, it is that very brief point in time and a little bit that follows when age is reset.
Hmm.
So remember, when an egg and a sperm from 30-year-old people come together, we don't get a 30-year-old baby. We get a
Hmm.
0-year-old baby.
Hmm.
And in that very brief period of time is when age goes back to zero, where all diseases in the genome are erased. We don't get babies that are born with Alzheimer's ever, and that's an extremely crucial time. And I say all ladies that are listening to the show right now, you're responsible for this. Take a bow. Men, unfortunately, we don't do too much in the process. Most of it is what's happening in the egg right
Hmm.
there.
Hmm.
A fabulous cell, an amazing feat of nature.
Yeah, and
Um,
it's interesting though that the egg, what does it know that there's multiple sperm trying to get it, and it lets one in and it closes the rest of them off? Is it fights them off, or was it? How's
it
it?
does a couple of things. You think of it the way we're taught, sort of back in school, is they race, and then that one sperm gets there and drills its way in, and it wins. It's very different, believe it or not. The egg actually has receptors on it that decide which one to let in, and it can sense which is more vibrant, which has the
Hmm.
most potent
Hmm.
uh, DNA that it would like to let in. And secondarily, really interestingly, and this has just been described in the last couple of years in literature, those sperm, millions of them are racing
Hmm.
to find that one egg.
Right.
They communicate with each other during the process because they don't have brains. They don't have eyeballs. They got to find this thing in a pretty big haystack,
Hmm.
and so they're working together as this team to figure out where the egg is. So in many ways, they're not competing with each other. They're helping at least one get
Hmm.
there to do the job.
Well, when you look at the classic Frankenstein novels or movies, you always see the doctor trying to capture some lightning to reanimate dead tissue. And when I saw the illumination there, I mean, when does life begin is a question. And I mean, and I don't, I guess I could do a little religious here, but say the spark of God, the type that makes somebody human, the instant time, the time. There must be a time when a person becomes life, when life exists. So it just seems to me, I don't know. It's interesting. It illuminates like that, like you would think some sort of spark of life is there, because there has to be, isn't there in the cells? There's always a sort of an electrical component to it.
Yeah, we're electrical right now. I mean, we have electricity running through our organs, through our skin. Every cell, even our DNA, communicates electrically and magnetically. I mean, that's how 50 trillion cells on a daily basis do everything so perfectly. I mean, it's not random. There are patterns in that electricity. So, yeah, Mary Shelley and Frankenstein had a component of that. And electricity, this incredibly
Mm-hmm.
powerful force of nature,
Mm-hmm.
zips around at the speed of light, getting things done, is not only up there in the sky, but it is flowing through our bodies as we speak.
Mm-hmm.
Our brains generate electricity. Our heart, pancreas, bone, we are very electrical
Mm-hmm.
beings, and we forget this.
Yeah. In fact, I think we had a guest on that actually said our heart generates more electricity than any part of our body, which is fairly interesting. So I'm wondering, do you use any sort of voltage process with dealing with cells and tissue?
Yeah, absolutely. We have a it's funny. We work with eggs in the lab because eggs are such a potent cell, especially because they have this ability to reset age. And so one of the things we do we don't have a lot sperm sitting around. We have a lot of eggs, and we zap them, for lack of a better word. We use various electrical fields and magnetic fields to stimulate eggs as if they were fertilized in the first place.
Mm-hmm.
And this gets them going through the process of their biochemical age resetting
Mm-hmm.
and all the benefits that they take off. So yeah, but electricity, magnetism, a lot of this comes into play in regard to our research. The answer is not just in sort of the biological component. It is controlling all aspects of it, and electricity is a big component of that.
Mm-hmm.
Secondarily, we are also involved in some of the tools on the one program I was telling you about in regard to the brain death research. There, coma patients and people in persistent vegetative state are routinely zapped with various devices to stimulate their brain to wake up at times in the ICU. So these tools are also a part of the picture. So electricity is, Mary Shelley was very prescient in her writing. It's a very important part of the whole puzzle.
YouTube commenter asked a question: do you think the electric spark is the beginning of a life?
Yeah, absolutely, absolutely. And we can debate, how much a person, should be there, and all
Well,
that business. But at the end of the day, life is life. I mean, it's alive,
well,
and
look,
it's.
okay. Well, look, we were talking about keeping people alive on machines, Ira, in the first hour. So, is it possible that, say, as one gets older, their voltage decreases, and instead of pills and blood and various things, maybe we should somehow increase the voltage to the body? What do you think?
Yeah, changes in membrane potentials throughout the body are involved in every disease, cancer, and all sorts of other conditions. You see the electrical potential on a cell that has cancer versus a normal one is very different. There are companies going this path. I mean, my former employer, GlaxoSmithKline, recently invested, I think the number was $75 million in an area called electroceuticals, where basically they're saying, what does a drug do? A drug is dumb. It's a dumb substance. It doesn't do anything. It just takes electricity zipping along, and it amplifies it or it slows it down from a target. So they're basically saying, hey, maybe we could get the drug out of the picture entirely and just, as you were saying, either upregulate or downregulate the flow of bioelectricity. We'll see how this goes. But the fact that they're, I think, the third largest drug company in the world now, that they're getting involved in electrical therapies, says it's not a niche area anymore. Let's put it that way.
Well, in a more philosophical strain, obviously you're dealing with life extension, and obviously maybe with an end goal or end vision of immortality, so to speak, or at least extreme longevity. But have you come across a philosophical question of what is life? Personally, you personally.
It's one of those things that the more you spend in this business, and when I say this research area, becomes more and more, gray, because when you think of things like the fact that for the first 8 weeks of our life, developing in our mothers, we have no brain, but we are doing thousands of things as an embryo. We have no brain at that point, but we're chugging along. At the same time, there are many species on this planet that don't have brains. But they communicate very effectively, and they've been around for millions of years. So we have these definitions of what it means to be alive as a human, but then they smack us in the face with all the things that technically you can do when you're not. Just a side note: when we die, right, per the brain death definition, everything below the brainstem is chugging along just fine. It's amazing the amount of things a dead person can do. You can metabolize, you can have a baby, you can fight infection, you can spike a fever, you can grow, you can mature. So we have all these oddities, these situations where what we defined as living and dead are skewed, and this is really, I think, important that we re-examine it all and re-answer that question, because I can't say with all these situations what is life and what is death concretely.
Okay, you said there's a sort of a blurred line there between life and death.
Yeah, absolutely.
Well, let's just go a little deeper then, Ira. Why are we here?
Oh, we're gonna answer that question. Why are we here? Well, we are biologic life forms that carry on a very important role, in my perspective, in my sort of thinking about this, in the grander scheme of things. And we are part of a connection that extends to the very micro level of things, to the very macro. And you only need to see recent studies that show astronauts that we send up into the cosmos are different than the ones that stay down on Earth. And the ones in the International Space Station, they're slightly different than the twin brother that stays on the planet. And that lunar cycles and solar cycles affect our biology. And even time They're now showing in this evolving area of chronobiology. We are slightly different at 11 o'clock in the morning as a person than we are at 5
Okay.
o'clock in the afternoon. We are all connected. It's going back to this issue of sort of our place in nature. Everything is connected. We are not sort of an independent species that hangs out here. We're all connected with a much larger system. So why are we here? We're part of a big story that probably started 14 billion years ago, maybe longer. And we are part of an evolving story that will go on a long period of time. I do not believe it's random. Uh, I do not believe it's purposeless, and I do not believe the universe is a machine. There's much more to it.
Hmm. Hmm. So in the year 2525, is man still alive?
25.
That's
So
that's a quote from a song from the 60s.
yeah, I remember.
Okay, that's a philosophical question too. So all right, so if you had extreme longevity yourself, obviously your intelligence would be vastly improved as well, would it not? You'd have vast amounts of information. Would it be sort of that kind of doubling of information and knowledge, and then where would you go with that knowledge?
Where would I go? I would, well, hopefully, if we solve the problems that we want to solve in terms of health and disease and the human condition, we would be able to solve the issue of energy. We would be able to solve the issue of agriculture. We would be able to solve the issues with regard to cleaning this environment and all these sort of geoengineering dynamics. And then we get on to bigger issues, whether that's terraforming Mars or other exciting things. I'm a comic book fan, a science fiction fan growing up.
Mm-hmm.
I think there's a lot of exciting stuff.
Mm-hmm.
Do I personally want to be around 1,000 years from now? I don't know. We'll see 500. If I, but I think we'll find enough things to do to keep us busy as a society.
Since I like to mention movies, the movie 23 grams, I think it's based on the fact that when a person dies, their body weight decreases 23 grams. Is there any truth to that? And if so, where'd that what left the body there?
I've seen the movie, and actually, there's papers that have been published on the so-called electromagnetic time of death, about the energy that leaves the human body. Look, no doubt. You and your history, and from the point in time you were born to your death, is not just the machine of a body that you're given. I mean, you are thinking, you are creating, and you are constantly putting information out there. Your brain is constantly producing electromagnetic fields and sending information out. That information is not destroyed. It goes somewhere. Whether it's 23 grams or 21 grams or whatever, whether it goes into extra-dimensional space, I don't know the answers to these questions. Mm-hmm. But I do believe it goes somewhere. And that there is a reason why, as I said early on, many species can have their brains destroyed and somehow remember things when the new brain grows back. Mm-hmm. It's also the reason that we have all these weird phenomena now on this planet of, children that are born without cortexes that are conscious, and children that can remember or know things about World War I fighter pilots that they never could have met down at University of Virginia Center for Perceptual Studies. So there's a lot of things that are just unexplainable nowadays, but we need to explore them.
Some evolutionary scientists get to something called irreducible complexity, and when you get down to those levels, a lot of times they end up questioning whether or not they can continue with an evolutionary type of belief. In other words, irreducible complexity indicates something was there in one piece and could not be the summation of various parts. So therefore, it indicates something was already there. Who put it there or how it got there, I don't know. I mean, I guess one could ask that question too. In your research, have you, as you look at life and you look at the cells, and are you like totally amazed at what you see, the complexity of life and how things do things. Like you said, operating from a fetus, doing things without a brain or whatever. Does that amaze you? Have you looked at it and said, "Wow, I can't even believe. I don't even know how it does this. It's doing this." I mean, what do you get to that kind of thinking?
Yeah, I've always thought that way and been in awe of it. Look, we have 50 trillion cells, each with 25,000 genes, each undertaking hundreds of thousands of chemical reactions every day. You just multiply those numbers together and just think, is it random that this is all happening that perfectly, or is there a higher level set of instructions? Yeah, I mean, we see irreducible complexity everywhere in nature, and it makes complete sense. Whether the conclusion is that God gives those instructions in the past and sort of gives the formula, or whether it's that, this evolving area of retrocausality, which actually the information is from the future and dictating back to the past. I don't know the answer to that one either, but
Wow.
I'm open to both possibilities. The point is, yes, even in the 14 plus billion years that this universe has been here, there's not been enough time to yield all possibilities just randomly. It is such a fascinating, complexity and complex situation we live in. There are definitely other forces involved in dictating what's going on here.
To just to finish up on that train of thought, I read, is it within the realm of possibility somehow that in your research and your drive in developing this company and the things that you do, is it possible way back in your consciousness you're actually looking for God or evidence of God? Just throwing that out there. I'm not saying you do or not. I'm just saying, is that ever could that be a component of what drives you, and maybe subconsciously, maybe even?
Possibly. I mean, I'm a moderately religious person. I'm spiritual. I do believe in, sort of non-local stuff. I have a childish openness to all possibilities. Whether I'm looking for God per se, or whether I'm just looking to get closer to some of the big questions that science has either forgotten about, or they've chosen no longer to go down this path because traditional science won't allow us to. That's a possibility. But either way, I'm about searching for truth on all these fronts and seeing what we can uncover.
Okay. And I guess in sort of the different area of that, we have something called consciousness. Is that in the cellular structure of the brain? Is it separate from the body itself? Do you have any ideas on that?
Yeah. We are, there's basically two schools of thought nowadays. One is sort of what's called this connectome model, which basically says Daniel Ott, Ira Pastor, so forth, we are nothing more than the few ounces of goo inside our skull, and that's all we are. Half the other world believes that that's not the case. They believe that the mind, consciousness, the soul, whatever you want to call it, is not something that's in your skull. It is a process. It's about relating to things. The rest of your body, its environment, its social networks, and so forth. And, if we miraculously were able to take out, Daniel Ott's brain and store it in some tank and keep it alive, that's not Daniel Ott anymore. So our bet and our position is that you are far more than just a few pounds of goo inside your skull. And there's just too much information out there, whether it's about the removal of the brain or whether it's about the turnover or just a lot of these weird things that you see popping up in the literature in terms of people born without cortexes or savants that get smashed in the head one day and can play Mozart the next, even though they never had any musical training. Consciousness, the mind, is something much bigger than just the goo in your skull. We view it, as the analogy, much more like a television set than a computer. That There's no little Kim Kardashian inside my TV set right now. Uh,
Hmm.
uh, that's not the way the system works, obviously. The brain is much more complex than that and doesn't just store information, it picks up information from
Hmm.
various places.
It seemed like I read an article that somebody had their blood, or some part of their blood was in Europe, and here in the United States where they were, something happened to their blood. But they said the same thing that happened to their blood here happened to it over there. Was over there. I'm not sure what exactly that was. I think it's translocation or something, or maybe
Mhm.
there's a connection to your.
Right.
I think I don't know if that's consciousness or not, but perhaps there's something that connects through time and space who you are. I mean, that you can't see that maybe be connected. But how do you respond to critics that may suggest that you're maybe you're going to start a zombie apocalypse, Ira, by what you're doing over there?
I would say I get that one a lot. No, I would say stop watching TV. If you want, I point out if you really want zombies, there's plenty of technology, marketed technology nowadays, whether it's delirium drugs or various microbes that already create zombies and zombie animals and so forth all over this planet now.
Mm-hmm.
I even call some of the people walking around or driving with their cell phones on zombies.
Yeah,
But
no
no,
doubt.
the phenomena of the Hollywood zombie, in essence, somebody who is a corpse that all of a sudden can be completely locomotive
Mm-hmm.
and think, because remember, zombies in the movies, they don't want to eat other zombies, they want to eat the fresh people.
Whoa.
All of that stuff has nothing to do with sort of
Mm-hmm.
what we're working on. We're basically working on neuro repair at a very basic level in the central nervous system, and how we, whether it's somebody who has recently been in a trauma or is deteriorating from Alzheimer's disease, how we bring back that part of the brain.
Mm-hmm. Why is it so hard from patients dying of incurable diseases to get into compassionate use programs?
Because people that are no option in the United States and abroad, that reach that stage where the medical community does not have answers for them, that are close to death or have terminal diseases, drug companies typically do not like to have them in their studies. If you die in a pharmaceutical company study, it goes on the record that you died because of the drug. And this is a problem. And so a lot of drug companies, it's why we only have a couple thousand cases where people actually get into clinical trials in so-called expanded access programs, when there's millions of people out there that are no option every year.
Mm-hmm.
And so we have this program in the U.S. that sort of allows it, but not as many drug companies take advantage of it. And we need other models.
Mm-hmm.
And other countries are actually moving a lot faster than the United States now in terms of how we get access to those that are dying to experimental therapies. Very difficult in the United States.
Mm-hmm.
And we're really going to have to really change a lot of laws. And we see some of it now coming from the Department of Defense, actually, as opposed to the FDA, with regard to how to get this going. But it's the U.S. program is behind many other countries on this in this regard.
But other countries, they don't have the regulatory constraint that the United States does, do they? Wouldn't they be much further ahead in this type of research?
I mean, they have this regulatory issues. They're just a little more open to the concept. Like Japan, as an example. Japan recently instituted what's called conditional approval, which basically says, if you're in phase 2 development of a drug that is working well, and you're dying of, God forbid, pancreatic cancer or something of this nature, you should be able to sign a waiver and say, look, I will accept trying this new drug at an earlier stage. And I don't care if, oh, wow, a lot of people got diarrhea while taking it. Who cares? I'm dying of pancreatic cancer. I want to try this drug. Mm-hmm. So companies like Japan are very open to it. Even a recent deal was done with the government of China and Merck, fifth largest drug company in the world, where they set up an island off the coast of China, a tropical island, where you can now go if you're dying of any cancer, and you can try Merck's immunotherapy products on this tropical, beautiful island. You go rest
Wow.
and take some experiments. So there's other countries that are thinking outside the box on how we can deal with these problems because
No,
we got a lot of patients.
I absolutely
Yeah.
agree. If somebody signs a waiver, why would the government step in and say we're not going to let you do that? That's ridiculous. How much further could we be ahead in this technology if they would just get out of the way?
Right. It's a great balance, and many people don't realize that the greatest discoveries that of all times that ever happened in this industry, penicillin, insulin, aspirin, smallpox vaccine, quinine for malaria, it all happened before there were regulations of any type. I mean,
There
they
you
were
go.
back in the 1920s. So we've got to balance regulations with safety and a little more common sense on some of these issues.
All right, we have this question here. It says, "Are you?" Wait a minute, I lost it. Hang on for a second. Let me get back into it. Uh, Okay, it says, are you aware that there's a company that has been doing experiments in India on a brain dead patient using stem cells trying to reverse the damage?
Yeah, it's us.
That's you.
Yeah, that's one of our partner companies over there. Yeah,
What?
India has been a very open country in the sense of how we conduct living cadaver research, and there's also obviously because of the
So you can't do
reincarnation.
that here, but you can do that there.
Oh no, we can do it in many countries. It's completely legal. The issue in the United States is that ICU costs here are about $10,000 a day. End of life care in the U.S. is the most expensive care of any type. In
What if you?
India,
What
you're talking about the
I remember.
south.
What if you brought a cadaver back to life and the person woke up and said, "Man, look, I was having a good time where I was. Why did you bring me back?" What'd your answer be?
If that's the case, we'll say we're sorry. Tell us what you learned, because
Wow.
no one has ever been through that window.
Yeah,
Obviously, people have come
it can
back from
happen.
clinical death, from heart and lungs, not breathing, but the death of the brain. If someone comes back and has stories for us,
Hmm.
well, that's an entirely other discussion, and we'll answer many other questions that
Well, I mean, you can say,
that
"Well,
we've
look,
been
man,
asked.
look, we can kill you again. We brought you back to life. We can kill you. I mean, whatever."
Yeah.
But
But
no,
tell us first about what you learned on the other side.
you're right. Now that's interesting. You want to know what's on the other side. So where do you go when you die?
Good question. I mean, we
That's why
know
you.
we
That's why
know
you want to ask the cadaver that you just reanimated.
that it will be a question for the cadaver, because if they come back as we
Hmm.
expect,
Hmm.
with faculties in order, and not a blank slate, it will be a case of someone looking through the ultimate window. And once you look through that window and tell us what was on the other side, we'll know a lot more than we know today.
Hmm.
Um,
And we've had a number of people on this program, Ira, that say they've been over there. So I got some ideas of what's happening. But so, if your technology that you use, what shows the most promise?
um, the core promise is in the biologics that we're developing for things like spinal cord regeneration and cancer reversion.
Hmm.
So these are biologics. So when I say biologics, these are protein-based therapies,
Hmm.
no genetic engineering. These are not tissue engineered products, and they're exciting not only because of their use, but because they're inexpensive. They're in the sense of traditional pharmaceuticals. We're not talking about anything here, for $1 million a shot, like some of these gene therapies and
Right.
things, other stuff. So people always get the question: is this only for rich people? No, we made the decision when we first set this company up that we are only going to develop products that fall in the typical development model of a pharmaceutical company.
Hmm.
So we're not talking $1 million a shot. We're not talking things here that only Bill Gates and Warren Buffett can afford. So we're very excited with regard to that platform. Stem cells, as in the case of the brain death work, that's a secondary aspect, because in there we're merging both the biologics and the stem cell approach. Slightly different program,
Hmm.
but
Hmm.
the biologics are really the most exciting for us.
Hmm. Have you mentioned rich people? Have you had people come to you and say, "We've seen your research, and I want to live forever," and I got unlimited resources to make that happen? Has somebody ever asked you, approached your company to say, "Look, how much you need so I can live forever"?
We've not had that. We've had a lot of, we want to enter clinical studies today, um, in the U.S., and that's, because our U.S. program is still a couple of years out. A lot of our clinical research is going on in other countries, just because, as you mentioned, the regulatory opportunities allow us to move quicker. So we are able to, in certain cases, refer patients to other clinics and other hospitals around the world now. But yeah, I mean, we're still. No, the trillionaire benefactor hasn't come to the table yet, but we're
Mhm.
okay with that right now because we're moving along at a good clip anyway.
All right. So where do you see this technology in 50 years?
Oh, in 50 years, we will. I've put it on the table that the reversal of death will occur well within that window,
Really?
most likely in the next 10 to 20, if
Hmm.
not sooner. Death is one of those things in terms of brain death that
Well,
only has one cause.
well, Ira, you could inadvertently uh, cause the reverse of a zombie apocalypse. You could cause overpopulation if nobody's dying. I mean, what's the answer there? I mean, it's going to look like we're going to have Soylent Green going on here.
Yeah, well, that situation will not occur until somebody solves all of the aging problem, and most people will point out that death rate is not the issue with regard to population. A lot of really evil people have tried to control populations using death rate in 20th century, and it doesn't work. Birth rate is the main problem, and once again, I go back to if we have the ability to solve these problems in terms of health and disease, I think a future society that has those problems off the table can deal with uh, unlimited food supplies and energy sources and all the other issues that come to the table. But
Well,
clearly, society will be different at that point, and we will have to answer new questions, no doubt.
okay. Well, there's a billion people in India. What if you end up with 5 billion? Because nobody's
Yeah,
dying. I mean, there's not going to be any
that
attrition either.
yeah. I mean, there's definitely a responsibility at that point to the system.
Hmm.
Because yes, there is a limit, but a lot of that, once again, we'll have to. It's more than just. We can't say we don't want to cure people of Alzheimer's and cancer and heart disease because of overpopulation. We're going to have to come up with other solutions to that issue,
Hmm.
which, in my opinion, are as equal, if not more, on the birth uh, rate
Hmm.
side of things as they are on the death rate.
There seems to be a uh, a uh, a rule law line that does not allow humans to crossbreed with animals. Do you feel like though that was maybe something that just that particular thing there, among others, that there are lines that are out there that you cannot cross, and there are things in place from wherever that is that will prevent you from reaching your goal?
No, because we're not crossing, and we're not crossing species or genetic engineering or anything like that. All we're doing is finding the tricks via traditional pharmaceutical approaches
So what
to
you're saying is,
stimulate
if the
cellular
knowledge
regeneration.
can, you're saying then, if the knowledge and the technology can be achieved, then it was already approved. Let's just say, from a celestial standpoint,
Oh yeah, I mean, with
if
it,
you could reach what you intend to, then if there was that line, you couldn't reach it, right? But so you're just going to keep going until as far as you can go.
yeah, I mean, there's a reason why humans and other species can't mate. There's a reason why, hey, even two humans get together and miscarry all the time. There
Mm-hmm.
are instructions. There is information, let's say, in biological systems that
Mm-hmm.
prevent stuff from happening.
Mm-hmm.
So if it's natural, fine. But if it's against the, let's just say, the law
Yeah.
of the cosmos,
Right.
yeah, yeah.
The prime directive. I mean, suppose there's a limit to humans can only live to 120 years. You'd never be able to surpass that. That's if there is a limit. I guess we don't know. But the people have lived
That we
past
don't know.
120 anyway, right?
Right,
So
right.
what is the? Do you know what the oldest person's ever lived is?
Almost 123. Madame Jean Clement in France smoked until she was 102. That we know. And she ate a lot of chocolate too.
We got a couple quick questions, and we're getting near the end of it. It says, why does the FDA allow drug companies to sell meds if there are so many harmful side effects?
Because the main goal of FDA is to balance so-called what is called a therapeutic window. Nothing is harmless. No foreign substance that you put in your body is 100% harmless. Even water.
Okay. Is there any esoteric based slant to your work?
Um, yes, in the sense that there are many, as I mentioned earlier, esoteric concepts that we have known about for decades now that are unexplainable, and work like ours, helps answer. And whether that is, where the mind goes upon the death of the brain, or how memories come back, or how children know things about people from 100 years ago that they never met. All of these things are more esoteric concepts that we hope we'll be able to answer in due time.
All right, Ira, Pastor, I appreciate you coming on the Edge television broadcast. Any final statement about your website or anything you do you'd like to say? Go right ahead.
Just come to the website. I just want to, I like getting the message out that as much as this industry has been seen as, boring or promising things that are always 30 years away, it is a very promising coming decade. And whether it's the 100,000 people we lose every day of aging, or the 50,000 we lose to trauma, we have an ability to really make an impact in the coming years.
Okay. Well, Ira, Pastor, I appreciate you coming on the Edge television broadcast tonight.
It was a pleasure. Thanks for having me.
All right. Good evening.